Hello ladies and gentlemen, this is Mr. Cunningham. What I'm going to show you how to do today in this video is how to make a solution, okay? So again, at the beginning of this unit, I told you guys part of your test is that you're going to have to make a solution for me, all right? So I'm going to show you how to do that right now. Since our last lesson, which was over doing calculations, how to find molarity or how to use molarity to find moles or to find volume or to find even grams, I'm going to show you now that you know how to do those calculations, I'm going to show you how to make a solution. So here's the thing, here's an example of what I might ask you to do on your test, okay? It'll be almost exactly like this, all right? I will say make 30 milliliters of 0.25 molar COCl2, all right? So you're going to have to do that. So here are the steps, all right? The steps of that are, first, you're going to use your molarity equation. Molarity is equal to moles divided by liters, to solve for the moles of solute. Remember, it's moles of solute divided by liters of solution. I just abbreviated that so that it wouldn't take up as much space. So I'm going to use that equation to solve for moles of solute. All right, so I'm going to do that real quick. So molarity equals moles divided by liters. Well, it says that it wants me to make a 0.25 molar solution. So molarity equals moles over liters. So it gave me the molarity that it wanted me to make. So I'm going to put in this 0.25 right there for for molarity. Then I need to take this volume and it needs to go down here for liters. Now the issue is this is not in liters. I have to change that to liters. Something you might want to memorize or make sure you know how to do the dimensional analysis for, I'm going to go ahead and do it down here, is I need to change 30 milliliters to liters before I can plug it in here. Okay? So I'm going to take my 30 milliliters and I'm going to divide by 1,000. How I would write that in dimensional analysis is like this, okay? Because I want my milliliters to cancel. So basically I'm going to take 30 and divide by 1,000. That is going to be equal to 0.03. So this 30 milliliters is 0.03 liters. I am going to take that number and it's going to go down there for liters. So right now, here's what my equation will look like. I've got 0.25 equals, and again, moles, I'm going to put in X for moles. 0.25 equals X divided by 0.03 because that's how many liters I have. So now I'm going to solve for X. Well, that's pretty simple. I'm just going to multiply both sides by 0.03. So these are going to cancel out over here. 0.03 times 0.25 gives me 0.0075. Now, what is that unit? Well, remember, that's for moles. So that's how many moles of this compound I need in my solution. Okay? Now, since you're going to actually make this solution, guess what? Scales don't measure out moles. So here's where you need to change your moles to grams of solute. So again, COCl2 is my solute. All right? So I need to change that many moles to grams. Well, I went ahead and did this earlier. In order to change grams to moles, I need to figure out what the molar mass of that compound is. Okay, so I went ahead and added it up. It is 129.83. Okay, that's the molar mass of COCl2. So what I'm going to do is I'm going to take this many moles, which is 0.0075, and I'm going to multiply by its molar mass. I'm going to erase this for now. The molar mass, so that's how many moles of COCl2 I have. I'm going to multiply times the molar mass, which is 129.83. and that gives me 0.9 7. Okay? So, here's what that means. That is how many grams I am going to need to put in my solution. If I want to make a 0.25 molar, this is cobalt 2 chloride solution, and I need it to be 30 milliliters in volume, I'm going to take this many grams of cobalt 2 chloride, I'm going to measure it out on a scale, and I'm going to put it inside of a graduated cylinder or volumetric flask. Then I'm going to add a little bit of water. I'm going to try and get as much of it dissolved as possible. Then I will fill it up to 30 milliliters. Make sure it all dissolves. Then I will have 30 milliliters of 0.25 molar cobalt chloride. So now what I'm going to actually do is I'm going to cut away. So the first things you guys need to do is do calculations, okay? Because you need to figure out, since it gave you molar, you can't measure any of that stuff out on a scale. You need to get to grams. Grams is the stuff that we can measure out on a scale. This is how many grams we're going to measure out, okay? So after your calculations, that's when you'll actually start putting this stuff together, okay? So I'm going to cut to kind of our lab scene, and I'll show you how to do that. All right, so here's all the things that you're going to have when you need to make your solution. So obviously you'll have your scale. Here's your compound. This is the cobalt 2 chloride. Now there's two pieces of glassware that I want you guys to become familiar with. This one in this hand is called a graduated cylinder, and then this right here is called a volumetric flask. Both of these pieces of glassware are used to measure volumes accurately. Now, graduated cylinders, these, are not as accurate as volumetric flasks. However, you guys are going to be using graduated cylinders to make your solution. The reason why is because they are reasonably accurate to multiple different volumes. Volumetric flasks are extremely accurate, but they are only accurate to one specific volume. So for instance, on here, this is a 250 milliliter volumetric flask. So I would only use this container if I were going to make 250 milliliters of a solution. If I was going to make any other volume, I would not use this piece of glassware because it is super, super accurate, but it is only accurate to 250 milliliters. Remember, in our problem, we needed to make 30 milliliters of solution. So I'm going to use a graduated cylinder. Now, the first thing we need to do is we need to measure out. Do you remember how many grams? It was 0.97 grams. So we did our calculations. We solved to figure out how many grams of this do we need to put in our solution. So I'm going to measure that out now, and I need 0.97 grams. So you use your spatula, and I need to measure out 0.97 grams. Now, because you are trying to make a precise amount of, or a precise molarity, I went a little over. I got 0.98. Now I'm going to try and get as close as I can. If I can't get that down to almost there. It's at 0.978, so I'm going to try and take a little bit more out. Got down to 0.975. This is where it can get a little bit difficult. All right, I got 0.973. So that's going to be close enough for our purposes. So then what you're going to do is I'm going to measure out, I just measured out 0.97 grams, and I'm going to put that into my graduated cylinder. Now, remember, the volume of our solution was supposed to be what volume? Well, it was supposed to be 30 milliliters. Now, one mistake that a lot of students make is they forget to put it to 30 milliliters. Now, how these graduated cylinders read is, hopefully you guys can see this, on the right side is measuring up. So right here, this line is 10 milliliters, then up here is 20, then 30, 40, 50. So if I want to have 30 milliliters of solution, I need to fill it up to this line. Now, on the other side, it actually counts down as you go up. This is so that if I had 40 milliliters and I wanted to deliver 10, it would just go down to here. So again, you want to pay attention to the numbers on the right side of the graduated cylinder for your volume. So then I'll take my water bottle and I'm going to fill that up to 30 milliliters. Now, something you might want to do, something that I will have there for you is, just because I fill this up to 30 milliliters, okay, now, one thing you don't want to do is, you don't want to overshoot it, because you can't take water out. Because as soon as you add water, guess what? Some of that substance dissolves. So if you were to remove water from the solution, you'd be removing a certain amount of moles, which means your solution would not be as accurate. Now, the reason why is this crystal down here hasn't dissolved yet. So what I will do is I'll give you a pipette. That serves two purposes. The first purpose is I need to make sure all this dissolves. And remember, a factor, we talked about this in one of our earlier lessons, a factor that affects how quickly something dissolves is agitation or stirring. So what I'm going to do is I'm just going to suck up some liquid and push it right back out. That will help my solid dissolve. Okay? So now I haven't gotten quite to 30 milliliters yet. I'm at like 27 milliliters. So what I need to do is I need to come back over here and I need to add a few more milliliters to get that up to 30. There we go. Now I got it to 30 milliliters. And not all of it has dissolved quite yet, so I'm going to try and get all that to dissolve. Now, it looks like it's about all dissolved. So now here's what I have. I have 30 milliliters. Again, the problem said make 30 milliliters of 0.25 molar cobalt 2 chloride. So I've got 30 milliliters. Now, how I know that it's 0.25 molar is I did my math and figured out how many moles I would need to put in 30 milliliters. So if I had messed up, let's say that I accidentally added this up to 40 milliliters, I would not have 0.25 molar cobalt 2 chloride anymore because I measured out 0.97 grams. I could change that to moles, but instead of dividing by, remember in our problem we divided by 0.03 liters, I would have to divide by 0.04 liters. So that would not give me 0.25 molar. So you have to be really careful with this and make sure you don't overshoot your volume. Now, if you overshoot it by a tiny bit, that's not going to make a big deal. But if you're supposed to have 30 milliliters and you accidentally go to 40, that's going to be an issue and your solution would end up being wrong. Okay? So again, how we make a solution is we do the math first to figure out how many moles we need of our solute. Then once we know our moles of solute, we have to change that to grams because scales can't measure moles of solute, but they can measure grams of something. Then we measure out that amount of grams on our scale, we put it in our container, and we dilute, we add water to the volume that we did our calculation for. Okay? Hopefully you found this video helpful. If you have any questions on how to make a solution, make sure you let me know. And thank you for watching.